G'day Bifrosters, let's do a Houdini. Yeah, let's do the simplest Houdini node. Let's do peak. This one's real easy and should be really quick because Bifrost already has a node that does this. So I'm just going to create a platonic solid. It's going to be an icosahedron. It's going to be triangles, about 12 subdivisions and a radius of 10. There we go. Nice sphere with lots of nice normals and things on it. We'll drop it into Bifrost, kill our input because we don't need it, hide our sphere, and we're ready to go. Right, scale along normals. It's this easy. Let's place points. And then let's just close this down. Don't need that right now. And then change this number. There you go, done. Alright, I hope that helped everyone. Have it. Oh, hang on. Hold on. Just had a thought. Oh my god, is Val doing performative? Oh, he might be doing performative on his YouTube videos. That's bad. Here's a scatter. Oh, it doesn't work on the scatter. That's interesting. I bet you it does if I turn it into points. No. There you go. Well, I think we can do a little better than that. Let's have a crack at making this work for points. So, of course, to get some points, we'll need some points. So let's scatter points. We could use my scatter on object node too, but it's a bit old and broken and I'm about to release a new version of it. So let's just pop this in here. I think 1,000 points is fair. Let's just let's take a quick look at this by putting down a point scope. Point scope into the output. Turn off that one. There it is. Lovely. So scattering off that object, which has been displaced right now, which is why it looks smaller. Pop that back in there. Pop that back in there. There we go. And the points are being coloured by their normals right now because they have a normal. So that could just be our answer, to be quite honest. It could just be our answer indeed. If we just put these in here, does this work? No, doesn't appear to be. Oh, I see why. Yes, it actually is. I think I saw it moving. We need to pop that into there and turn that off. So is it working now? Yes. So that's our answer. We can do it by turning our points into a point object, which is like, remember that this was just scattered points on an object right now. It's not until I put it into a point scope that it turns into something that resembles geometry. So I think we might have found our answer there. So let's really quickly make a compound that'll take either or a mesh object or a points object. And for a points object, I'm just going to, hey, let's do our old favorite. Get point count, put down a resize array, stick that into the size, and now we've got an array of that size. Oh, let's get even better. Let's use a random value array like this. Size, seed, and the offset. And a value node, and we'll just pop down a, yep, so that's a random value array. Let's get a point scope and construct points. Like that. And to there. Let's make that a sphere because I like them. Terminal, and to diagnostic. Wow, it's a random value array between 0 and 1. So what's 1692 points between 0 and 1 look like? So let's make that just a little more pretty. We'll stick in a set range in there, and we'll go from -1, -1, -1, 1, 1. So now we've got a cube like that, which is great. And so how on earth are we going to make this work? Well, let's just straight up through our constructed points in there. That's in our point scope. Let's go to, yeah, no, point's good. No, sphere. Sorry, sphere was good. But you notice that they're black, but in the point scope, we've got point normal. It's because these don't have any normals. They're literally just random data thrown in there. So we can do the same thing. We can give them a random normal if we want to, because it's the same format as this. All we'd have to do is normalize. And then after I construct points, we'll just set point normal. And let's chuck that into there. And suddenly you've got colour. Which is great. It's got our point normals. So now, with these point normals on, we can, hopefully, yep, now we can displace these. Because the normals are random, you're getting an interesting, no, sorry, because the normals are 0 to 1. You notice that I went out of the random value array to normalize, where what I should have done is gone out of here to randomize. And these are being pushed out along the normals now. So it's like 2, 4, 1, 0. So that's just where it was. We can also go -2, -5. Starting to see how they're looking a bit like a sphere? That's because of the random normals. So that was just a little bit of a quick diversion into random, because you apparently can't make a video shorter than about 15 minutes long. Let's make our own displace point. Oh, let's make our own peak, but we'll just use displace points to do it, because this method works, and that method works happily. I mean, it's still being converted into points because for some reason I decided to do that, but it still works. So, to do our own, let's make a compound. Let's spell a compound right. My Friday night videos after work tend to be a bit exhausted and silly, but that's okay. So let's get a geo in. Now it's at this point whether you decide, do I want to just do all of this outside, or do I want the ability to add points to this and set up some logic that's in there? I think I'm going to do maybe a hybrid of the two. Let's see how we go. So we got geo in, displace points, in there, out there. Let's test it. So far so good, looking pretty good. That needs to be a float, and then we just need to go, yeah, that's working. So that's the basis of it working. You've got geo and you've got your weights. Let's rename it to distance, just so we can be more like Houdini. Go back in here, and yeah, let's give us the ability to put some points in there. We won't worry too much about the logic just yet, but we'll use our same random value array. So let's do that correctly. Let's make a points in positions, and in here, what I'm going to do is I'm going to construct points out of that. But before that, I'm going to do a array is empty. So because this is always going to be a math float 3, there's an array existing here all the time. Whether that array has got something in it or not is a different story, and that's what this tests. So if there's nothing coming into this array, this will return true. So that means that if nothing is coming into the array, then that geo can go in. So it's true, it's empty. If it's false, if there is something coming in, if there's a points position plugged into there, then this geo can go through. And we'll pop that in there. You see it changes because we've got points hooked up. Let's just do a real quick layout and change those to S shape because they're tidier and easier to see. So all we've done here is we've added a construct points for our points coming in. And remember, out here we set our range. We basically haven't done any of this at this point. Let's just disconnect that guy and that guy, just to solve, to stop us getting confused. You can kind of see the points there. They've gone back to having no normals. So again, another decision: do we want to add normals coming in? Do we want to generate random normals inside? Or the other one you can do is use the point positions as normals, which is again just a matter of going normalize and then set point normal down there. Now that works. So this is pretty good for random stuff. If you actually want to carry the normals across, you might want to bring them in. So we'll give that option a go as well. So let's just pop these ones in for now. And this just means a little bit of logic. And again, it's a decision that we have to make as the person building the compound, is that do we want to put some logic on the normals as well. So let's just move that straight down to there. They'll be the same because that's what we did last time. And the question we're now set with is like, do we want to check if this array is empty as well? And do something if this is full and this is empty. Yes, this turned into a logic video again because logic's big and I'm trying not to just do 17 different lessons on it, basically. So what I would like to do is I'd like to check to see if there's anything coming into that plug. And again, I can do that with array is empty. Plug that one in. Do normals come in. So if normals come in, let's have another if. If normals come in, so if that is false, remember this is array empty, or array is empty. So if there's something coming in, if there's normals coming in, that will be our false. If it's true and there's no normals coming in, then in that case we can take the positions and normalize them, and that becomes our true case. So if our normal array is empty, it'll take our point positions, normalize them and use them as normals. That out there, and there you go. It's working because we have something coming into normals. But if you look this, that's interesting. So I should set that to yeah, that's what it was. I need to set that to a math float 3 array. I forgot to set array. Okay, because this guy is looking for an array. If it doesn't find an array, that means we can't set this as an auto port. This has to be positions, this has to be normals. This guy is looking for an array. If it doesn't find an array, then it's going to fail. It's going to crash out and say, I need an array or I'm going to die. Okay, so that's got just a little bit, it's got a new logic node described, which is array empty, or array is empty. And it's just showing you really quickly how you can make decisions based on whether these ports have got something coming in or not. And as an added bonus, we made another Houdini node, which was the peak node, which now allows us to, let's swap that for that, because it's more colourful. It allows us to, goodness me, let's get rid of our old graph where I was explaining things, because it's just obviously confusing. Peak. That allows us to now to expand or contract things along a peak. Now you notice that we've set up the logic that the mesh is no longer working. So the positions take priority. If I take that off, and again I'll need to make sure that that's set to array math flow 3, there we go. Now you see it's just pulling up the points. Well, it's using the sphere, but it's running through a point scope, so it's displaying the scope for me. Let's just switch that to proxy. So now we're back to our mesh sphere, and just to show you something fun, we'll do another displace points here, just like that. The weights are set to 1, and what we'll do is a fractal turbulence field real fast. That goes into the displacement vector, and suddenly, if I say drop my frequency, maybe not that much, like so, up my magnitude, suddenly we've got a bit of turbulence coming in on our platonic solid here, and it's a bit broken, but that's alright, it's just to show you. Then I can take this guy, hey, I spelled distance wrong, and let's scale him down a bit. You can see now that if I've got, say, a small magnitude, and then I scale this up, keeps being very small, but I don't need to put too much more on here to start to get quite a big effect from that turbulence field. So you can play with, you can chain these together and play with these kinds of things. You can also go inwards a bit. You're starting to get quite a good looking stone, worn down beach rock maybe. You go too far and you start to break your seams. But yeah, so there we go. That's basically just the Houdini peak node that generates normals for you if you want it to. Prioritizes the point object over the mesh object. Displaces points along their normals, and we're done. Well, I hope that one helped, and I will see you next time. Thanks very much.